Hi everyone, welcome to your lecture for the week. This week and next week we're going to be covering arrays and file I/O, and they're kind of a combined lecture, so I'm actually going to break it up. This lecture will just talk about file I/O and how to use file I/O, and then the next lecture we'll talk more specifically about arrays. And then after that we'll get into some more detailed things you can do with arrays, with strings and files and stuff like that. So yeah, let's jump into file I/O here. All right, so we'll talk about reading and writing to text files, and then in the next lecture we'll talk about arrays and how we use them. So up until this point, we've run most of our code using what's called interactive mode. So interactive mode allows a user to interact with the program while it's actually running. What this means is whenever you use a scanf or a printf, right, you're putting stuff onto that command prompt window, or you're taking stuff in from the user when requested from the keyboard. You are having the user interact with your program while it's running. So we call that interactive mode. Another way you can run programs is called batch mode, and that means once you start the program, it just keeps running without you having to do anything. So this would be like doing a bunch of calculations or taking data in from a source like a sensor or something. But what we're going to focus on here is I/O that must happen within a file. So we're talking specifically here about using files. There's two methods. One is called redirection, which we're actually not going to talk about, and this is how you interact with files in your code. The one we're going to use is a file construct, which is actually a structure. You'll learn more about structures in 226 or 224 next year, I think, when you take that, but I'll show you how to use this, and it's not too complicated. So there are only 4 steps for using a file pointer, and we need to remember to use every single one. None of them are very complicated, so make sure you write these down. We have to declare our file pointer and say we're going to use this file. We have to assign the file pointer and open the file, and the reason these are combined into one step is because we usually do them in the same line. We need to access the data, so whatever we're going to do, usually we're scanning it into our program to do a calculation or read in our data or something. And the last step, and the one that everyone forgets all the time, is that you have to close the file, and you do this using the file pointer. It's also very simple, just one line, but you can't forget to do it. It could corrupt your program if you do. So let's talk about step 1. We're talking about declaring a file pointer here. So the syntax, right, this is just the definition. We have the word file in all caps and then our pointer. An example of this, right, we always write this file in all caps. This is the structure syntax. I'm not going to go into more details on that. Just know that you have to write the word file in all caps. You're declaring basically a special type of pointer, which is a file pointer. So this special type of pointer is declared just like a pointer with the little asterisk, and then most of the time, you remember just like pointers, the convention is to start them with a P. For a file pointer, you usually start with FP. So this is FP in, which would mean file pointer input. So that's what we're seeing here in this example. Anytime you want to use the file construct, you don't have to declare a new library. It's listed right in the standard input-output library that you include automatically. You can think of a file pointer kind of like a bookmark. So all it's saying is, I need to know where my file is stored, and so I'm going to make a variable that just holds the address of where my file is stored. That way I can access it anytime I need to. So that's really all that's happening here. We're making a pointer. It's a special type of pointer called a file pointer, but it's nothing different than the pointers we've learned before. It's just saying, I need to remember where this file is located, so I'm going to just hold its address in this pointer, and that's all I'm going to do. Like I talked about, convention states that you start your file pointer name with FP, and then just like a regular pointer, we always declare that with the star. Okay, step 2. Assign the file pointer and open the file. So, like I said before, we do this in one step because we usually do it in one line. So, the syntax here is we're setting our file pointer, whatever we called it, equal to the function fopen. I'm guessing you can guess what that means. It means file open. And then we put our file name in here, and we put the mode. The mode is how we want to open that file. So do we want to open it and read in the data? Do we want to open a file and write data into it? Or the third mode is append, which just means I want to add data to the end of what's already there. If you open it in write mode and there's stuff in there, it'll erase it. Okay, so like I said, read, write, append. These modes need to be always lowercase, and they have to be in double quotes, just like this example. So I've set my file pointer I declared earlier, right? You'll see there's no star here. I'm setting the actual value of the file pointer equal to the address of this data location. So my file pointer equals wherever this text file is located, right? I'm going to open it, and then I'm going to open it in a certain mode. So we're just doing this all in one line. Now, this text file, if I do it like this, right, has to be in double quotes always, must be located in the same file folder as the C file that's opening it. So when you write your code, make sure you remember where you saved it, and you have to save this text file in that same folder. Now, technically, if you don't want to do that, you can actually write the full file location out and it will still be able to find it, but this can get really complicated and long. This would be like C:, my documents, \, EGR112, \, and then whatever. You can do it that way and it will work, but it's so much easier to just list the name in double quotes and just make sure that text file is in the same folder as your C file. Okay, now this first bullet point may seem like common sense here, but if you're trying to open a file, the file must exist. So if you're writing your C code and you're going along and you're just typing and you go to build it and run it, it's not going to open a file that's not there, right? So that makes a lot of sense. Just make sure you make your file first, and we'll actually put in a check to make sure that this happens. If you're opening to a write file, so if you have a W here instead of an R, if the file does not already exist, the computer will make it for you. So it will actually do all the work to create a text document for you. You don't have to do anything. If you're opening a write file and the file already exists, anything that's in there gets written over. So it's really, really important that you pay attention to your naming. Make sure you actually are opening the correct text document. Make sure this is correct, and make sure you spelled it right, because otherwise you'll start to get really confused when you either have data and don't expect it, or you don't have data and you're expecting it. Okay, so like I said, when you do the fopen command and you just put the name of the document, it'll look for any files in that current file folder that you're in. We also usually want to check to see if the file exists before we read it. So we always, when we're opening in read mode, want to check and see if that file exists. So let's look at an example of how to do that. We declare a file pointer, file all caps, declare that pointer just like normal, right? That's step one. Now step two is this line right here. We just need to open the file, that's it. This if statement here, you should always include when you're opening in read mode. So I'll walk through it with you so we understand. We just have an if statement, if fbin, so this is my file pointer. If my file pointer equals null, well, what does that actually mean? It means if when I assign my file pointer to this text file address, if that didn't work, my file pointer will be null. It won't have an address in it. If my file pointer is null, then I know something went wrong. So I can say this file does not exist, and then exit -1 is just an easy way to end your C program. So you don't have to do anything, just type exit -1. That's a standard function in the standard library. So no need to do anything else. This will just exit your program and they can try again. If you want to, you can actually combine that if statement and that second step into one line. So let me show you how to do that. Declare your file pointer, and then remember this part used to be FPIN, well, we can actually set FPIN and then compare it to null in the same line if you want to save a line. If this doesn't make sense to you or you don't like it's a little too complicated, it's fine to put them on two separate lines too. It doesn't matter. This does the exact same thing as what's on the previous slide. Okay, so step 3. How do we access the data in the file, right? The whole point of opening a file is usually to either get data from it or put data into it. So if we're using a read mode for our file interaction, right, we've opened it in R mode, we can use the function fscanf, and I'll, give you 2 guesses for what that means. It means file scanf. If you just write scanf, it will not work. So you have to use the special file scanf. The syntax is also slightly different, though very, very similar. We use that fscanf. We have to specify the file pointer. So this is the only additional thing we have to do, right? I'd have to put FPIN here. Then I'd have to say, right, my %d or %lf or whatever I'm reading in for my format string, and then where I want to save it. So let's take a look, right? If I'm scanning in just 2 variables here, I have fscanf, I have my file pointer because I have to know where to pull from. I'm scanning in 2 integers and I'm saving them in I and j. Now, what happens if I'm opening in write mode or append mode, right? Those are both writing modes. I'm going to use fprintf. You'll note it's not printf. Printf will not work. fprintf for file printf. And it's the same as the fscanf. So the only thing different from normal printf is that we have to add this file pointer. Okay, now you're probably like, well, wait a minute. Didn't we already declare a file pointer? We did. Do you remember what it was called, though? It was called *fpin. Well, if I'm taking an input, that would be a scan. But if I'm putting an output, I can't use that same file pointer. I need a separate one to be able to write to the file. So I'm going to declare another file pointer whenever I need to put something into a file, like write to the file. fpout is fine. You can call it whatever you want. fpout equals fopen data.txt_w. I still have to do step 2. I still have to tell it where I want to write to the file, where that file is located, and what mode I want it opened in. Now, if I'm in writing mode, do I need to check to see if the file exists? No, I don't, because even if it doesn't, it'll create it for me. And then the last step, right, we're accessing our data. We're going to print stuff into that file. In this case, we list the file pointer. We're going to print 2 integers, I and j. Now, can you use 2 file pointers in the same program? Yes, you absolutely can. You can read in from one file, you can write out to a different file. The very, very last step, and please don't forget to do this, is closing the file. It's extremely simple. For whatever file pointer you declared, you just have to close that. So I opened one file to read an input and I opened one file to put an output. So I just fclose and then I use the file pointer name. That's it. No ampersands or asterisks or anything, just the file pointer name. I have to say, hey, computer, I am done accessing the file located here, wherever this pointer says my address is. So don't forget to do this. Make sure you do close your file. Okay, so using file pointers are not that difficult, right? We declare the file pointer, we say file in all caps, and then usually *fp and then an input or output or whatever else you want to call it. We have to assign the file pointer and open the file. So if you remember, we set our file pointer equal to fopen, and then in double quotes we say the name of the file and then what mode we want to open it in. That would be read, write, or append. Now if we open the file in read mode, we do have to check and see if that file exists. After that, we are going to access the data in the file. If we're in read mode, we're going to use fscanf. If we're in write mode, we're going to use fprintf. Maybe you'll use both for 2 different files, that's fine. And then the very last thing, for every file pointer you declared in step 1, you need to close the file using the file pointer in step 4.